guys, this is The Sixth Sense. I'm Jazib, and today I'm going to cover up the topic volume and density in physics. Let's jump right into it. Volume is a quantity of space an object takes up. The SI unit for measuring volume is cubic meters. But this is a rather large quantity, so could say cubic centimeters or maybe even cubic millimeters for really small stuff. But in liquids, it's said liters, which is actually equal to 1,000 cubic centimeters or 1,000 milliliters, or it's also equal to 1 cubic decimeter. Now let's get into density. Let me ask you one question. What do you think is heavier? This rock or this rock? Well, you would probably say this rock because this one seems larger. So, if you guess this one, congratulations. But let me ask you this question. What do you think is heavier, this rock or water? Well, you'd probably still say this rock, except, that depends how much water compared to how much of this rock. So if we use all of this water compared to this rock, all of this water is definitely heavier. I don't even want to try. But let's say we use the same volume of water compared to the same volume of this rock. The rock is heavier, of course. It's a rock. So volume changes a lot when it comes to weighing something, but the reason this is heavier compared to the same volume of water is because this has more kilograms packed into this amount of volume. That is basically what density is. The formula for density is density equals to mass over volume. To make things simpler, you might have heard this for speed, distance, and time. We can make a triangle in which we can put the M on the top, M for mass, the P on the bottom right or bottom left, and P stands for density. You shouldn't get that mixed up. And V is for volume. So using this triangle, which looks like this, we can say that if you can just cover your finger and whatever you're covering is what you can find out. So you can say volume equals to mass over density, or density equals to mass over volume, or mass equals to volume times density. So using this formula, they will give questions like this, questions like the one I'm about to say, and it's not too hard to answer as long as you understand this triangle and what it means. Over here, it's given a chart in which it says some substances and says their density. It'll be right over here, around here. Should be, yeah, good. So it says some examples like substances like petrol has a density of 800 kilograms per meter cube, or we could use grams per centimeter cube, which in this case for petrol, it would be 0.80 grams per centimeter cube. And using this, over here they gave an example question. Let's read it out. Using density data from the table given, calculate the mass of steel having the same volume as 5,400 kgs of aluminum. First, we need to find the volume of aluminum. To find the volume of aluminum, we know that it is M over P, which is mass over density. And we know the density as it is given, which is 2,700 kg per meter cube. So to calculate the volume, we would do 5,400 kg over 2,700 kg per meter cube, which equals to 2 meter cube. So now that we know the volume, we need to do this. We need to find we need to calculate the mass for steel, and mass equals to volume times density. The density of steel is 7,800 kilograms per meter cube times 2 meter cube, which equals to 15,600 kg, which is, wow, that's a lot. So the mass of the steel is 15,600 kg. So that was the answer to the question. Now let's go to measuring volume and density. Measuring volume and density. Measuring volume. First, let's do liquids. A volume of about a liter or so can be measured using a measuring cylinder, which looks like this. There's a scale on the side of the measuring cylinder which will tell you how much water you put into the measuring cylinder. The mark will be measured in milliliters or cubic centimeters. For measuring a regular solid, it is also relatively easy compared to other stuff. Like for example, a cuboid or a cube, you do length times width times height. Or for a cylinder, we can do pi r squared times h, which is height. But how about measuring an irregular solid? This is slightly harder. You would have to place the irregular solid into a measuring cylinder with a bit of water. When you lower the rock into the water, because of displacement, the water level will rise. Displacement is which when you put water in, like if you put your hand into like a bowl or something, the water level will rise because your hand is taking up space. So the water will come above your hand, making the water level higher. So using displacement, we can find the volume of the difference in volume from the original to when the rock was inside. Well, that's the volume of the irregular solid. But for larger irregular solids, like a large rock or something, we would have to use a displacement can. A displacement can looks like this. There's a spout. When you fill the water to the brim, you can lower the large rock inside, and the large rock will displace water, and the water will come out of the spout, and you can put a bowl or something, or maybe like a bucket, or just maybe even just a small cup. And however much water is in that cup or bowl is the volume of the rock. Let's measure density. Measuring the density is mostly just calculations, because once we know the mass and the volume, we can measure the density because of the triangle, mass equals to volume times density, or density equals to mass over volume. So using this triangle, we can find basically anything out, from mass, volume, and density. So that's basically how we measure density. Now, let me tell you a story about how density even was founded. Archimedes and the crown. You've probably heard of Archimedes. He's a Greek mathematician who lived in Syracuse, which is modern-day Sicily, at about 250 BCE. He was famous for all of his inventions and discoveries, but he was most famous for solving a problem given to him by the king of Syracuse. The king gave a goldsmith an amount of gold to make him a crown. But after the crown was made, he wasn't too sure if the crown was completely made of pure gold, which he gave to the goldsmith. Maybe the goldsmith cheated him by mixing in some silver, which was relatively cheaper. He gave the crown to Archimedes and asked him to find out if it was pure gold or not. Archimedes really didn't know how to solve it, but one day he lowered himself into a bathtub and found out that the water level was rising. He got so excited that he found out what displacement was, and that he ran around the streets screaming, "Eureka, Eureka," which means "I have found it." He asked the king for the same amount of gold used to make the crown. He lowered it into water and saw that that the water level was rising. He did the same with the crown, the original crown, and found out that the water level wasn't rising as much as the same amount of gold in the previous test. This means that the crown must have been replaced with a cheaper metal like silver. So the king found out that the goldsmith was cheated, and Archimedes became famous. And that's the end of the story. Now let's get into more about mass and density, where we're going to learn about a beam balance. The beam balance is probably the oldest and simplest way of finding the mass of something. You put one object, like a rock or something, into one pan and add some standard masses like 1 kg of metal or 2 kgs or 500 grams into the other pan until it becomes level. When it becomes level, the amounts that you put on the standard weights is the mass of the irregular solid or rock or whatever. So this is a really old way, and it was used a really long time ago, and this is actually still used nowadays sometimes, but pretty rarely because there's a lot of advanced technology. This is actually compared to weights other than masses, because this uses gravity, which is basically mass times gravitational force equals to weight. So this uses weight because it pulls down. If it pulls down too much on one side, then you have to add more to the other side to make them balance. So when I was talking about how this is actually using weights instead of mass, well, mass times gravitational pull equals to weight. The gravitational pull unit in the SI unit is newtons. Now let me give you a fun fact. You probably know that Jupiter is the largest planet in the solar system. But did you know that Earth is actually heavier than Jupiter? Because Jupiter is a gas giant. It's completely composed of gas and maybe some other stuff. But Earth is a rocky planet which has a higher density. Because it has a higher density, it is heavier, even though it is much smaller. Jupiter, although it's big, has very low density. The Earth's average density is 5,520 kilograms per meter cubed. Jupiter has an average density of 1,330 kilograms per meter cubed. You can see the big difference in densities, making Earth way heavier. Jupiter is way larger, but Earth is way heavier than Jupiter. And if you made it this far into the video, well, that means you covered one topic. And you know, one topic a day keeps you bad grades away. So make sure to subscribe, turn on the notifications, and comment, and share this video, and do whatever you can do that's not unliking the video down below. And knowledge is the sixth sense. We'll see ya on the next one. Ask you a question. Which one of these rocks do you think is heavier?